Hello again. I know it's been a while. I've been busy with module building and going to train shows and all sorts of things. I thought I'd give you a little update and overview of what's been going on with the modules and what the progress is. So I ran into a problem at our last setup. These are my turnout throws with the blue points, which are actuated by this little throw rod with that plastic or nylon clevis down in here. And what happened was, there's the handle, so you just push on it and pull on it, and that's all the more actuation there is. But a couple of the guys had not looked at the points and pulled on this and pulled this clevis off of here. And so the only way to get in there to fix it was to cut through my burlap hardshell, which got it fixed. It didn't break anything, it just pulled it loose, and it was easy to pop back on. So I like that. Originally I had designed these for use with 2-inch foam. I'm getting away from the 2-inch foam, but this is one of the complications that happens. One, it was hard to mount my blue point up next to the faceplate because of this, so I had to chop a hole in there. And the other thing is I can't get to these rods to do any sort of maintenance. If I ever did have to replace something, it would be very difficult. So what I've done is make a little pop-out scenery door. Once this is covered with scenery, a little bit of spackle or whatever, you'll never notice that it's here. And to get into it, there's a hole below, so you can push up through there with a pencil and pop that thing out. And now I can get to the throw rods. So this is just a foam core that I've cut and made a couple of blocks to hold it up, and it slides in like that. Okay, and the hole bored through there, so I can pop it loose with a pencil. On this one, I put a little dam, and I will do that to this other one. So this butts up against the sub road bed, and this will be filled in with sculpt-a-mold and terrain, contoured to fit the terrain. I haven't figured out how I'm going to make the border around here. I will likely put a piece of saran wrap in and cover this piece, tape it down on here. Do the outside and then lay the saran wrap out and contour inside and let that dry, and that'll be my pop out. But that's the plan for right now. The other thing, I don't think I've explained this before, is I'm trying something new. Rather than build this out of foam, which is really, really messy, to carve like this, to carve out all this, the cut, you generate a huge cloud of foam dust. So to fill in these other places, I'm trying this burlap, and I'm going to put sculpt-a-mold on here, and that'll make a hard shell. We'll see how it works. The one thing that might be of concern is how do you plant trees in it. I'll cross that bridge when I come to it. The other thing that I've got going on is, as in usual, the modules construction, people decide different things. First we didn't have enough modules, then we didn't have enough passing tracks, then we didn't have enough yards, now everybody's built a yard, so now we don't have enough industries to switch. So what I'm in the process of doing is I've added this line in here to be a panel rail fabrication facility. So there'll be a yard here with a forklift, parking lot right here, and some kind of building out over here, and you'll be able to spot like 3 or 4 flat cars or gons with loads in them, and there'll be ties and rail and whatnot. So that's the plan. Now right here I have to make a curved switch because this is on a curve and it's not much of a curve, but it leads to a curve. So the way I did that is I taped a piece of paper down after I drew my tangent line that I want the siding to go out on, took a rubbing of the rails at this point and drew in my siding curve. And then I took that and put it on my scanner and scanned it in, used that for a base image in DraftSight, and calculated the curvature of the rail and got my tangent points, offset them, did all that stuff. Let's go inside and I'll show you how that works. So here you can see I've got my template for my curve switch all drawn out. The way I did this was draw it in DraftSight. These are my parts. I've got the points filed, and the frog pieces filed. So I laid out these curves, and then I used Tim Werris's Fast Tracks template, curved turnout template here for the placement of the PC ties. I could lay the point of my frog over the point of this frog and transfer the tie spacing onto my template, and that's a custom template. It's a different curve than what his is. The inside radius here is about the same as the outside radius on his, and this is the largest one that he makes. So I just customized it a little bit, and it should work fine. I'll have to adjust these ties after looking at it a little bit. Need to go further this way, give me a little more separation right in here. So I would probably put a couple PC ties right here, but the gaps are going to be out here and there'll be ties in there to support that. So let's look at the light box here. This is the light box. It's just one of these little craft containers. Nice, transparent. Has a nice flat surface with no texture on it. I could tape my paper or whatever to it. And then I bought an assortment of various little stick-up lights. These are just the little Harbor Freight. I think they're $2.99. But they've got two modes, so there's a huge amount of light coming out of all those little LEDs. Come on. And then this one has a light there. So if we put that down, get my track plan back over here, all my little rails on it. You can see it's got quite a bit of light, and you can trace through there. You see the pattern through there, and line it up and do what you need to do. Put it about like that. Yep. So that's how to build a really inexpensive light table. I looked at the ones that are LED powered, but they're $100 or so. This is a cheaper option. Since I brought up the light table, I thought I'd show you another tool that I've found that I really, really like. If you are going to work with foam and you have a jigsaw, this is a Festool foam cutting blade. It's quite long, I don't know, about 6 inches long or so, but it has this wavy knife edge, and it cuts through foam like butter and does not leave any, well, I shouldn't say any, but way less foam particles flying around than using a standard skill saw or knife or anything, regular jigsaw blade. I think it was $12 or $15 for the package of 3 of them. If you look up Festool. When I was talking about carving these hills, one of the things, besides the Festool blade that I used to make the curve, the Festool cut the curve for this, inside and outside and in here along the track. But one of the other things that I used for cutting the hump in it was my little Dremel oscillating tool. So that's right here. Okay, and that's the blade that I use. You can get pretty deep with it, and you can just jab in like this and shave, you know, make a cut and then pop that off, and that works pretty rapid for removing stuff and not creating a huge pile of dust. I got one of these little blades, which that's a heavy grit carbide blade. I have not used it yet, but I think it'll work awesome for doing the final contouring. It's just like a regular sand, you know, one of the mouse sanders. You can get into corners and all around places. So for rough, coarse things, it'll make probably a heck of a mess, but it should work pretty good. Because what I was using is the normal, you know, rasp. It's a slow process to shave this, and it makes lots of little flakes. Burlap is, I'm just using hot glue and slap, you know, run a couple beads, smooth it out with my hand, and you don't notice that the hot glue's there. And once you put a little skim of either Sculpt-A-Mold or mud, you know, the vinyl mud, I can't think of the name of it, but anyway, once you put that on there, I don't think you'll notice it at all. So that's my tips for this video, and talk to you later.